Okay, so another student request for problem 12.10, homework problem 12.10, and the question is, oops, lost my textbook. The question is on page 307, and starts out like this. In the discussion of black body radiation, the average energy of an oscillator, alright, so far when I'm reading something like this, I'm just lost, right? So I'm going to make some notes. The average energy of an oscillator is given by this equation, h nu over, what is it, e to the h nu over kt, okay, minus 1, right, which was approximated as h nu over 1 minus e to the h nu over kt plus 1. No, minus 1. Minus 1, okay? Which you can see is going to end up being, sorry. You know what, that's all mistake. H nu over 1 minus h nu over kt, rather, do it again, 1 minus 1, okay? You can see, obviously, that this is going to be equal to, that's 1 minus 1, h nu over kt, which is the same thing as kt, okay? So that's an approximation, and that is valid when for h nu over kt is much greater than, much less than 1. Okay, so if this is a small ratio, then this is an approximation, which is good. Alright, so the question is, calculate the relative error. First of all, calculate relative error, which is defined as E os minus E approx all over E os. Okay? That's the definition, and obviously this is going to end up just being a bunch of math, so I'm going to use Excel. But there's a deeper question here, and the question is, at what temperatures, or rather, at such and such temperature, right? Can you predict the sign of the relative error will be without a detailed calculation? So I'm looking at this and going, well, I don't know. I'm going to rewrite this out first of all to decide. So this is going to be, this is the relative error. This is the same thing as h nu over e to the h nu over kt minus 1 minus kt, right, because that's the approximation, over h nu over e to the h nu over kt minus 1. Oops, minus 1. Alright, I'm looking at this and going, I don't know, what's the sign of this going to be? Is this going to be negative or positive? Well, this clearly depends on how big kt is relative to this. Agreed? Is this going to be plus or minus? Okay, well, it depends. Which is bigger, kt or this mess here? Alright, so in order to approximate that, what I'm going to do is I'm going to take this, I'm going to rework it. This is going to end up being h nu, then it's much less than, I multiply both sides by kt. This is greater than less than signs, but these switch around if one of these is negative, but this can never be negative. That's temperature, which can never be negative, and k is a constant. So what this means is, what this approximation means, if this is a small ratio, much less than 1, basically close to 0, that means that this is much less than that. H nu is much less than kt. Alright, so we need to think about, so if that's true, then this is going to be big relative to that. Okay? And I'm going to say if kt is much, much bigger than h nu, then relative error is likely to be negative. Okay? And I think the last question that I have for you, and you know what, I don't have my problem set out here in front of me, but I think the last question was, what does this mean? You know what I'm going to do? I'm going to look it up real quickly. Bear with me. What does this mean? Downloads. How does the relative error change as the temperature decreases, and why do you think that is? Okay. Well, this makes some sense. The relative error, here's the relative error right here, and you can see that as this number gets smaller, this difference is going to get less, right? So as the temperature decreases, I'm expecting the relative error to decrease. As T gets smaller, KT goes to 0, and then the relative error goes to what? Oh, you know what? I should let you answer that. As temperature goes to 0, KT is going to go to 0. What's the relative error going to go to? It's not a 0, by the way. It's the question mark. That's for you to answer. Okay. So I think the rest of this, what I'm going to do is I'm going to open up a spreadsheet, and I'm going to calculate my relative error for these 3 different temperatures, which are 5,000, 1,500, and 300 K. And presumably, as this gets smaller, my relative error will also get smaller. Alright, and then the question for you is, what's the lower limit on that? I'm going to do that in Excel, hopefully make a video of that and post it as a separate video. Hope that's helpful.